Welcome back, Agent. We just discussed how to use regular strings for pattern searching when using regular expressions library. Now let's move on to the key part of regular expressions, which is the special pattern codes you can use to build out your own pattern sequences. We'll start off by discussing character identifiers, and here we have a table that tries to explain what each character identifier is. Basically, you'll have special character identifiers that start off with the backslash code and then a letter indicating what character you're referencing. So to start off, we can look at this example, backslash d, and this description is a digit. Essentially, you would have this as a placeholder for any digit. So in your example pattern code, you could have a string file underscore backslash d, and it would look for anything that holds that pattern, file underscore, and then 2 digits following it. For example, file underscore 25 would match this pattern code. Here we can also see there's alphanumeric, basically indicating letters or numbers, so alphabet or numerical, and that's backslash w, and this is what an example pattern code could look like, backslash w dash and then 3 backslash w's. And that basically says any letter or number followed by a dash and then followed by 3 letters or numbers. And alphanumerics also include things like underscores, so keep that in mind. Then there's white space. So if you're particularly looking for white space in the pattern, you can say backslash s, and that indicates a placeholder for white space. So an example pattern code for that would be the letter A backslash s, the letter B backslash s, letter C. And what this does is it indicates that you're looking for A, white space, B, white space, C. So here we have an example match. There's also a non-digit character placeholder, which is backslash capital D, and you can think of the pattern here as lowercase is a digit of lowercase d, and then uppercase d is a non-digit. So you can see how these are related to each other. And backslash d, backslash d, backslash d, where they're all uppercase, is going to match up with, for instance, this pattern, ABC, because none of these are digits, and they're all in a row with each other. You also have non-alphanumeric and non-white space, again, the capitalized version of their counterparts. So here you can see some various example matches. Let's begin by checking out that example with the telephone number. We will say our text variable is my phone number is 408-555-1234. And then we will say phone is equal to re search. And if we actually search the phone number itself, 408-555-1234, in our text, we'll see that phone is that match object saying where it found it span. However, we may not always know the actual number. We just know the pattern, where it's 3 digits, a dash, 3 digits, and then a dash, and then 4 digits. So what we can do is replace this using the pattern character identifiers we just learned about. In this case, we're looking for a digit, so we will use backslash d. So we'll say backslash d, backslash d, backslash d. Then we expect a dash, 3 more numbers, another dash, and then finally 4 numbers. However, recall that when working with strings, these backslashes indicated special escape characters, such as backslash n for a new line or backslash t for a tab. To tell Python that we're using these as a pattern for a regular expression, what we do is we add an r right in front of the string. So that basically tells Python that these aren't really escape slashes such as new line or indicate tab. Instead, we're using them as a pattern for our regular expressions. So that's why you see this r in front of the strings when working with patterns for regular expressions. So let's rerun this cell and now see what our phone object is. And you'll notice the phone object is, again, the exact same thing. It's a match. But if I were to change these numbers around, so I said 7777 for the text and rerun these cells, it would still get the match. Before, it would not get the match because it's looking for the exact numbers. Here instead, we're doing a smarter approach where we're actually searching for the pattern itself. And if you ever wanted the actual number, you could say the phone object here, you see the span, and if you call the group method we discussed earlier on it, it returns the actual piece of string that matched. So this is how you could actually grab that phone number itself. Now notice what we did here. For every single digit in this phone number, we wrote a backslash d. But what if we were looking for a pattern that included 20 digits or 100 digits? We wouldn't want to have to write backslash d 20, 50, or 100 times. For this reason, we can use quantifiers to indicate repetition of the same character. So we already know our character identifiers. Now let's learn about the quantifiers, allowing us to not have to write these multiple times. So here we have the quantifiers table, and basically the way the syntax works is you stick your character identifier, and then immediately after it you stick this quantifier if you want to indicate a certain quantity. So you have various quantities you can choose from. There's the plus symbol indicating that the character identifier occurs one or more times. So an example of this pattern code could be version \w, so that's alphanumeric, dash \w alphanumeric plus. So what this plus indicates is that you're looking for \w one or more times. So an example match could be a-b1_1. So all of these are alphanumerics that occurred one or more times. Recall that underscore counts as an alphanumeric. Now let's imagine you wanted something to occur exactly n amount of times. So exactly 3 times, 4 times, you get the idea. You can use curly braces in that sense. So you would stick on your character identifier. In this case, we're looking for \D, indicating a non-digit, and we want this to occur exactly 3 times. So an example match would be ABC, 3 non-digits. If you want a range you're looking for example, occurs 2 to 4 times, it's the same curly braces, except now you indicate the lower limit, comma, the upper limit. So \d, curly braces, 2, 4. An example match could be 1, 2, 3. Another example match could be 1, 2 or 1, 2, 3, 4 because we're looking for a range here. Alternatively, if you're looking for 3 or more or some n number or more, so you don't want to set an upper limit, you can just say curly braces, your lower limit, comma, and leave the upper limit blank. So \w along with curly braces 3, comma, no upper limit. Basically that just says 3 or more alphanumerics, go ahead and match them. So you can see any characters here, that string will match because it's 3 or more alphanumerics. And now you can see how regular expression code can get a little complicated quite quickly because you're adding character identifiers and quantifiers. But if you break it down, you'll be able to see what the actual pattern code is asking for. The next quantifier we can look at is an asterisk here, and that basically indicates if it occurs 0 or more times. So here we have an example pattern code, A, then asterisk, B asterisk, and then C asterisk. And what that is asking for, does A occur 0 or more times, followed by B occurring 0 or more times, followed by C occurring 0 or more times. So there are a ton of actual patterns this could match up to. For example, AAA, then 2 Cs. That indicates that A did occur 3 times, B occurred 0 or more times, and then you have C occurring 2 times. So very powerful here, and it's going to match a lot, so keep that in mind. And then you have a question mark here indicating once or none. So here we can see plurals, question mark, indicating does S occur once or none. And so an example match could be plural or it could be plurals. So either occurs once or no times. All right, let's see how we could transform our original search for a telephone number using quantifiers. We'll place our example phone, but now we know the actual amounts we want, so we're going to replace this with our character identifier and then saying I want exactly 3 numbers, then a dash, then another 3 numbers, and then we want 4 numbers. And this is now a regular expression pattern code for a phone number with dashes. So we can run this and see that if we check our phone, we get back the same match here because we're asking for 3 digits in a row, followed by a dash, followed by 3 digits in a row, followed by a dash, followed by 4 digits in a row. Now let's imagine that we wanted to do 2 tasks. One was to find phone numbers, but then also to be quickly able to extract their area code. That is the first 3 digits of the phone number, these first 3 digits right here. What we can do is we can use groups for any general tasks that involves grouping together regular expressions, and that allows us to later break them down. So to do that, we need to learn about the compile function. So we will say phone underscore pattern is equal to re compile. And what compile does is it compiles together different regular expression pattern codes. For example, the first pattern code we see here, that's just a single pattern code. But what we could do is think about it as 3 pattern codes connected by this dash. So that's exactly what we're going to do here. We will say R, and then our quotes, and in parentheses, we're going to group together 3 pattern codes. So the parentheses indicate that it's a group of a pattern. So the first one that's going to go into first parentheses is this one right here, \the curly braces 3. So there's our first group, and then dash, and we're going to do our second group, which is actually the same thing. And then the third group is going to be with the 4 here. So what this does is it takes multiple pattern codes, and each pattern code is separated with parentheses as a group, and then it compiles them into a single expression. So what this is going to do is it's going to compile these into this expression that we see right here. But what's nice about using the compile is that it still understands that these were 3 separate groupings. So you could call the groupings individually. So we've created our phone pattern using the compile function. So if I say results is equal to re search, and I search for the phone pattern in my text, and then I say results, and I group them together, I see here 408, 555, 7777. Now what I can do is say results group and call them by the group position. And the groups were denoted by these parentheses. So if I want the first group, I can say group 1. And notice here in a little bit of a differentiation from normal Python code, we don't start indexing at 0, we're starting at 1. So group ordering starts at 1. So if I grab those results and I group, and I just say group 1, it only returns back the first group here. So if I wanted group 2, essentially that second set of digits, I could say group 2, and it would return back 555. And if I wanted the third group, I would say group 3, and it would return back 7777. And if I ask for a group that is outside of this, such as group 4, it's going to say, sorry, there was no such group. Because here we only had 3 sets of parentheses. First group, second group, and third group. What's nice about this approach in regards to our first approach is that now we can easily extract parts of that information while at the same time looking for a complete match. So if you just call group with no number, it groups together all the patterns you had in your compile function, and it returns back the whole match. So if you wanted to find phone numbers, you could just use this approach and then group them together. And if you wanted to find phone numbers and their area codes, you could use group with nothing and then say group 1, and that returns the area code. So that's why the compile function along with the group method is so powerful. That's it so far for quantifiers as well as the compile and group function. Up next, all we have left to talk about is some additional regular expression syntax, such as wildcard characters and then or pipe operators and stuff with like starts with or ends with. Let's quickly review what we covered here. Basically, we discovered that if we don't want to repeat character identifiers often, what we can do is use quantifiers. And we have various quantifiers indicated by a special character. Then there's a description here, and we can essentially tack them on. We also learned that if we want to grab subsections or subgroups of our entire pattern, we can use the compile function to create the actual pattern instead of just passing in the pattern as a whole string, separating each group with parentheses. And then we can say group together off of the search results in order to grab everything together. But if we only want to grab subgroups, we can say group and then that group position, where group positions start at 1. All right. We'll see you at the next overview where we're going to talk about some additional regular expression syntax.